Okay, so again, this hash function that I defined totally works, right? But it creates a table that is incredibly sparse, and that's not good. We don't want that. So what if I made my table size, exactly the same as my data with my hash function that I have right now? So I could make this hash table size 5. I know I have 5 students, so I only really need to store 5 things. What would happen if I were to do that? Well, if I were to run my code here now and look at how this is adding, first I go to add Sam Studier, and he's at position 3, right? Because 123 mod 5 is 3. So we put him in the table there, no problem. Go to add Pat Procrastinator, whose ID is 514. They're at position 4. Okay, no problem. Go to add Ollie Overachiever, position 0, no problem. But now we get to Sid Slacker, whose ID is 99, which also mod 5 is 4. We go to add him at 4, and there was already somebody in space 4, but now we've just replaced them. And obviously that's not good. We've lost a piece of data. So we can make our table smaller just fine, but we can't do it with the hash function we have right now because here we have a collision, right? We've tried to add Sid Slacker at position 4, but we already had somebody at position 4. So we now have 2 values, Sid Slacker and Pat Procrastinator, who have the same hash code. Their hash code is 4. And we can't put them both in the same place in the array with the way that we're doing it this time. So we need to resolve that somehow. So this example, I'm going to use linear probing to resolve this collision. So we're going to have to update our add function to reflect that. Okay. So again, in our previous add function, we just put the student right in that place. But this time, when we put the student in that place, there might be somebody already there. And if there is, we need to resolve that collision. So what's going to happen is with linear probing, what we do is we say, okay, well, there's no room here where I'm looking. Let me just look one index up. And if that index up is free, I'll put the student there. If it's not, I'll keep looking. Okay, so that's what we're going to do here. So I'm going to modify this code. So it's going to start out the same way. I'm going to find my hash code. Null. Okay. So I want to do this as long as if the hash code is if the hash table at this location is null, that means it's empty, and I can just put the student right there, right? So if this is not true, if I do find a null, I can just add that student. But if I don't find a null, that means there's somebody already there, right? So what I can do is I can say, oh, okay, that means I'm going to include some print lines so we can see what's going on here, that I have a collision at position, whatever position I'm in, hash location. So what I need to do is check the next position. So I just need to increment my hash location. Now, I might find myself running off the end of the table, right? So let's say I tried to put someone in position 4, and there's already someone in position 4. Well, this is going to now increment hash location to 5, but 5 is out of bounds. So when I increment my hash location, I also want to take, again, a modulus of table size. So this is saying, okay, if I tried to look in 4 and 4 is full, I increment to 5, but 5 doesn't make sense. So let me take 5 mod table size, which in our case is 5, and 5 mod 5 is 0. So it's going to bump that around, wrap that around the array. Make sure you understand how this part of the modulus works and post questions if you don't. So now I've got a new location to try. So I'm just going to indicate that in my print line. Okay. And I'm just going to keep doing this until I find a position that's free, meaning that there's nothing stored there, meaning that it's null. So as soon as I do that, my while loop will fail. And I now know that hash location is a place where there's nothing in the table. It's null. So I can just go ahead and add the student there. And this is where I'll put the code that I already had before, where I add the student in, only now I'm not adding them at hash code. I'm adding them at hash location. And then I will indicate that and print my table. Okay, so this is, again, now how I add my student using linear probing. I come in here, I find their hash code. Initially, I'm going to try to just put them right in the place of that hash code. But first, I'm going to check and see if there's anybody already there. If there is somebody there, meaning that the hash spot If I've wrapped around at the end of my array, I'm going to wrap around and try again at the beginning. And I'm just going to keep doing that. Check and see if there's somebody there. If there's someone there, move to the next spot. If there's someone there, move to the next spot. Once I find a spot where there isn't anybody there, that's where I put my object. And that's it. Okay, so this is going to be my new add method. So I'm going to, let's print out, let's see how this works in my driver. So when I run this, first I add Sam Studier. I'm added at position 3, right? Because Sam Studier, there's nobody at position 3. The table is empty right now, so I add him in, him or her in. Then I try to add Pat Procrastinator. They're going to be added at position 4, right? There's nobody at position 4, so there we put Pat Procrastinator. Now we try to add Ollie Overachiever. Their hash code is 0. We tried position 0 and it's free, so we put them there. Now we get to Sid Slacker. So Sid Slacker's hash code is 4, but there's a collision at 4 because we already have Pat Procrastinator. So again, we need to now try position 0, right? Because we would increment 4 to 5. 5 is outside the range, so it wraps back around to 0. But there's also a collision at position 0 because we have Ollie Overachiever at position 0. So we need to try the next one. Position null, there's nobody there. So we add Sid Slacker at position 1. So now this is what our table looks like. And then we try to add Alex Ascalot at position 2. It's open, so we just add Alex there. Okay, so there we go. That's our new add method that uses linear probing to add students in the right place. But now we have, in the rest of our driver program here, remember we tried to find the student with ID 99. So in our find method, what we did is we just find the hash code 4. We go and we look in our table position 4 and we say, okay, return that student. But now that's not the right answer anymore, right? Because in position 4, it's Pat Procrastinator, and that is not ID 99. So in addition to updating our add method, we also need to